Hello. In the last video lecture we studied resistance firing circuit. So SCR firing circuit we were studying, and we discussed resistor firing circuit or resistance firing circuit. So we can see here. So this was the circuit we discussed. Okay. Now the next type of triggering circuit is resistance capacitance firing circuit. So here you components you observe, you have a source voltage ES, a load and voltage across load is EL. SCR you have two diodes, you have D1 and D2, and one variable resistor and capacitor. If you compare this circuit diagram with the previous one, what are the changes? We have actually RB, there we have a capacitor, and one more diode is used. Okay, so that is the change we observe in the resistor capacitance firing circuit. Now let us see how it operates. Okay, so let us start with the negative cycle. During the negative cycle, what happens? You observe negative cycle means this side is minus and this side is plus. During that time, this SCR will be reverse biased, so it will be open. But what about the diode? This diode, you observe one path is this one and positive terminal is connected to this. So this diode will be forward biased because negative is at the top, positive at the bottom. So diode is forward biased and capacitor charges to negative Emax. So if voltage source is swinging between minus Emax and plus Emax, your capacitor voltage charges towards minus Emax because this is a minus sign, because it is a negative cycle. So once it reaches the maximum value, that is minus Emax, then the capacitor voltage remains at that value till the input source changes from 0 to passes through 0. Okay, so that's why it is written the dotted line is the capacitor voltage. Once capacitor voltage reaches minus Emax, it will stay there, and when input voltage or source voltage changes or passes through 0, this diode will be then what? It will be reverse biased. Then capacitor will be charging towards plus Emax or plus Emax, but the path will be like this. So path will be, let me use this color. Now this is positive and this is negative, so diode is for reverse biased. Now the path is this is the path for positive. Okay, so what happens? That's why the capacitor voltage charges towards the upper side or towards the positive side. So what happens? When it is getting charged, the voltage at this point, when it reaches the gate trigger point, or when it attains a voltage which is sufficient to trigger SCR, that time SCR gets triggered, because SCR needs a forward bias voltage that we are giving in the positive cycle, and one more thing it needs is gate supply. So gate voltage should be sufficient to trigger. So when it reaches that value, the SCR will be triggered. So when SCR is triggered, then what happens? So voltage across load is nothing but the voltage, the source voltage. Source voltage will appear across the load. That's why in the EL we have seen this voltage. So it follows now what? Our source voltage, because this act like a short. This act like a short. And capacitor voltage will be fixed at the positive, a small positive voltage. Again, when during the negative cycle, SCR gets as SCR will be turned off because of the reverse bias, and same thing continues during the negative cycle. Again, capacitor voltage charges. Okay, so it attains minus peak. Again, it charges towards the positive when it reaches a value. So this is the point. You observe this point. At this point, the voltage at capacitor will be sufficient to trigger the SCR. So that's why it starts conducting, and you will see the voltage across the load. Okay, so here alpha is the angle between this. What is the advantage of this circuit is we can have a larger value of alpha that we were not able to get in the resistance firing circuit. So that's what here in the explanation written. By using RC network, a larger alpha angle can be obtained. During the negative half cycle, capacitor charges through diode D2 to minus Emax. That's why the orange color what it is shown. As SCR anode voltage passes through 0 and becomes positive, capacitor begins to charge through RV from minus Emax. That's why when it crosses the 0, the green line, you have to see the green line, the capacitor charges towards the through RV, okay, now from minus Emax. When capacitor voltage reaches to gate trigger voltage, so that means voltage at this node is sufficient, that is nothing but VG1 mean plus VD1. VD1 is required because I have to forward bias this diode to trigger the SCR. So when that voltage reaches VG mean plus VD1, SCR gets triggered. So we can write a formula when SCR gets triggered. When our source voltage is greater than IG mean RV plus EC. Just observe, yes, when the voltage across this, I am talking about voltage across this, what happens? So it should be, that is nothing but voltage across RV and voltage across capacitor, that is nothing but the ES. So when it reaches what value? When it reaches IG mean into RV, because the current through this one should be what? Total voltage across this resistor and capacitor is nothing but the supply voltage. So when it reaches, you can take down that, you can IG min into RV plus EC. So I am adding these two voltage, one voltage is this, another voltage is this. This together should be sufficient so that our gate is, gate voltage will be sufficient and SCR gets triggered. So that's what written, ES should be greater than or equal to IG min into RV plus EC. So what is the EC? EC is the voltage across the capacitance. We already discussed, it should arrive at a point which is sufficient to trigger SCR. So that one is written here, VG min plus VD1. So EC voltage should reach VG1 plus VD1 and total voltage will be IG into RV plus this EC, that EC is nothing but VG in plus VD1. So that is what here written. So that should be equal to IG min into RV plus, instead of EC place I will write VG min plus VD1. So the maximum value of the RV, you can take RV this side and you can find this equation. So ES minus VG min minus VD1 divided by IG min. That is the value of resistor required to trigger the SCR. So it should be able to generate enough voltage at the gate. Okay, thank you.